Hello, everybody. We're going to talk about section 3.6 today, and it is about applications of linear equation and modeling. And in this section, we'll be doing a lot of the interpretation of the graph, and also do a little bit of prediction, so a little bit of a interpolation and the extrapolation. So, all right, let's go ahead and get started. Let's go ahead and look at number 2, interpreting the linear equation two variables. So here we have a graph of the federal minimum wage by year along with the equation. Right, the line we have here is it's called a best fit line, but now sometimes the best fit line it's not going to go through every single point, but we're going to use that to estimate. So okay, all right, so let's go and look at the description. This graph describes the minimum hourly wage in dollars per hour in the USA, and we can use the equation y equals 0.14x plus 1.60. And they're also telling us that the x represents the number of years since 1970, and gave us a pretty good example of x equals 0 represents 1970. So let's go ahead and look at the question. The question asks, use the equation to approximate the minimum wage in the year 1980. So in this case, we need to know that 1980 means x equal to 10, because they said when you got 1970, x equals 0, right? So which means 1980 is 10 years after 1970, so x will be equal to 10, and we're just gonna plug that into our equation. So y equal 0.14 times 10 plus 1.60, and this means 1.40 plus 1.60, which equals to 3. So that means in 1980, the minimum wage was $3. Okay, simple as that. Now again, I was 2 years old in 1980, so I obviously and I wasn't in the United States yet, so I don't know what the minimum wage is. So if you ask your parents, they'll probably tell you. All right, number 2, use the equation to estimate the minimum wage in 2021. So let's see how close we are compared to using this model here. So 2021, right, minus 1970, that gives us 51. So in this case, x equals 51. Let's plug that in. So you have y equal 0.14 times 51 plus 1.60. Again, I don't expect you to do this in your head, so please use a calculator. 0.14 times 51, that is 7.14 plus 1.60, and that's going to be 8.74. And right now, I'm not quite sure what the federal minimum wage is. I think it's $7.25, maybe. I don't remember. So you might have to look it up. But according to this model, this is what we should have in 2021. Okay. All right. Now let's go ahead and look at part 3. Determine the y-intercept. Interpret the meaning of the y-intercept in the context of this problem. So remember, right, when we talk about y-intercept, that means x value equal to 0. So if we plug in x equal to 0, right, or if you notice, this right here, equation is y equal mx plus b. So which means you could tell what the y-intercept is by simply looking at the b. So in this case, we have 0, 1.60. And remember, right, since I said x equal to 0 represents 1970. So this means in 1970, the minimum wage was $1.60 per hour. Okay, so back in 1970, it was $1.60 per hour, and that is what our y-intercept is. Okay, so just remember, there will be a lot of interpreting, a lot of explaining, they want to make sure you know how to, read the graph, how to calculate, and how to, how to connect, the meaning between the graphs, the math, and the actual explanation. All right, let's go ahead and move on to the next problem. Let me erase this. Oh, last part, determine the slope. Almost forgot. The slope is, again, y equal mx plus b. So slope is 0.14. But in this case, because this is a story problem, so make sure you include the units. Now, 0.14, we can write it as a 0.14 over 1. And then we're going to use the labels for each x and y. So notice that x is year. And minimum wage is y, that's $1 per hour. And since the slope is positive, so we know this is increasing. So that means the slope of 0.14 means each year the minimum wage is increasing by $0.14, right? By $0.14. So basically $0.14 per year. And that is what the slope means in this case. All right, let's go ahead and move on to the next question. All right, so now this problem, again, if you have the picture pulled up or printed out, you'll be able to see it, see the problem on the other page. Apologize ahead of time that I ran out of space, so I had to split up the problem. The graph shows the rising numbers of jail inmates in the USA since 2000. Two linear equations are given. One describes the number of female and one to describe the number of male. And let y be the number of inmates in thousands, and x will be the number of years since 2000. Okay, let's go ahead and take a look, see what we have. All right, so let's take a look for part one. Part one, what is the slope of the line representing the line of female inmates? So notice female inmates is the reddish, pinkish line there. So the slope in this case is 4. And remember, right, just like the previous question, this is a story problem, so we need to make sure we attach some labels to it, so we can have some context. So 4 you can write as 4 over 1, and again is 4,000 over 1 year. And the slope is positive, so which means this is increasing. So this means the number of female inmates is increasing by 4,000 per year. Okay, so there's a little bit of context. Now part 2, same idea. What is the slope of the line representing the number of male inmates? Interpret the meaning of the slope, context this problem. So for the guys, you got y equal 19.2x plus 544. So the slope for the guys is 19.2. So which means 19.2 over 1. So same idea here, just like the first problem with the ladies. This means we're increasing the number of male inmates is increasing by 19.2 thousand per year. Okay, so again, some interpretation isn't much needed. Now part 3, what group has the larger slope? what does that imply about the rise in the number of male and female prisoners? Well, guess what? If you look at it, the guys have a bigger slope, right? So 19.2 is definitely bigger than 4. Okay, so the explanation we basically already said up top. The slope tells you about the rise and the decline of the male and female prisoners, and it looks like in this case, the population of the prisoners they're increasing and not decreasing. Okay. All right. So now let's go ahead and answer the last question. Assume the trend continues. Use the equation to predict the number of female inmates in 2022. So remember, for female inmates, the equation is y equal 4x plus 71. And since we're talking about 2022, if I take 2022 minus 2000, this tells me 2022 is 22 years after 2000. So x equal 22. And then all we have to do is just plug it in. So y equal 4 times 22 plus 71. That's 88 plus 71, which is 159. And this means in 2022, based on this model, we should have 159,000 female inmates. Okay. All right. Hopefully this is okay. Well, let's keep going. All right, number 3, write a linear model using the observed points. The figure shows a relationship between a person's height in inches and the length of the person's arm. All right, so now in this case, right, we're supposed to write a linear equation. And remember, a linear equation, we have learned so far, there are 3 forms, right? You have the y equal mx plus b, you have y minus y1 equal x minus x1, right? And remember, we said those 2 are the most popular form that we're going to use. So first thing first, let's find slope. You happen to have 2 points, so we're going to use those 2 points to find the slope. So m equal y2 minus y1, so 82.25 minus 57.75 over 24 minus 17. Again, I'm not going to ask you to do this in your head. So 82.25 minus 57.75. 82. Just double check. 82.25 minus 57.75. That is 24.5. And 24 minus 17 is that is 7. So 24 divided by 5. Sorry, 24.5 divided by 7, we get 3.5. So this is not bad. So what this is telling me is that the slope is 3.5. So now I'm going to use the slope and one of these 2 points to write my equation. So I'm going to use the point slope form. Got y minus 57.75 equal slope, which is 3.5. Multiplied by x minus, let's see, I use the 57.75, so 17. And from here, we are done. We're done finding the linear equation. Notice, the question did not say to use the slope-intercept form or point slope form, so you can pick whatever form you want. Okay. All right. Now for part two, we already figured out what the slope is, but now just to make sure we explain it. So we know the slope is 3.5 over 1, and let's go ahead and attach the labels. So the y value is the height in inches, and the x value is arm in inches. So which means this looks like, because it's 3.5 over 1, so it sounds like for every 1 inch growth in arm, it's equivalent to 3.5 inches in height. Okay. All right. Definitely an interesting question. I had those. I actually had one of the students measure my arm, and it was off by only a couple inches. So it's fairly accurate. Okay. All right. Let's go ahead and move on to the next problem. Okay. Now, for the third part, we did not. I don't think we did the third part in class, but you could definitely try to measure somebody's arm and use the equation to estimate how tall a person is. Now, I'm not quite sure how accurate it's going to get, but you can definitely try to see the accuracy. All right, part B. The graph shows the average height of a boy based on age. Let x be the boy's age, and the y be his height in inches. Okay. So part 1, find the linear equation that represents the height of a boy versus his age. So basically, you're just trying to find the equation. So I will use. Let's find the slope first. Slope is 51 minus 36 over a minus 2. 51 minus 36 is a 15. 15, a minus 2 is 6. And 15 divided by 6, I believe, is 2.5. So we know, so from here, right, we have the slope. So I'm going to go ahead and use one of the points. I'm going to use the point slope formula. So this is y minus 36 equal 2.5 times x minus 2. Using point slope. Okay. So that'll take care of part 1. Now part 2, now notice I had a typo here. I meant to say use a linear equation find in part 1 to predict the average height, not age, height. Okay, so to figure out this kid's height is based on the equation, we're just going to take the number 6 and plug it in. Okay, so we have y minus 36 equal 2.5 times 6 minus 2. Y minus 36 equal 2.5 times 6 minus 2. 6 minus 2 is 4. 2.5 times 4 is 10. So add 36 to both sides. So y equal 46. Okay, so based on this formula, if the boy is 6 years old, that means that his height should be 46 inches. Okay. All right, let's keep moving. All right, the last part. What we did was in in class was that we just want to make sure we can set it up. And then once you're able to set it up, you can solve it on your own. Part 4, so number 4, we need to write a linear model of a fixed value and rate of change. So part A, a storage space charges $90 a month plus a non-refundable deposit of $50 to rent a small storage space. And we need to find the equation to compute the cost Y of renting the small space for X months. So from here, it looks like because the monthly rate is $90, so this could potentially look like total cost is the monthly rate times month plus let's see, plus the I guess what you saw the setup cost or the set fees. Okay. All right. So which means in this case, what we know our rate. Our rate is $90 a month, and then we have a set cost of $50. Okay. So that means our equation is going to look like this. Total cost is 90 times the month and add 50. Okay. All right, so check this out. So part B, we need to figure out the cost for renting the storage for 6 months. So it just means we're going to plug in 6. So total cost is going to be 90 times 6 plus 50. So you should end up getting 540 plus 50, which is 590. So $590 for part 2 of the first part A. All right, same here for part B, same idea. Let's figure out the equation for it. High-tech home improvement buys a fleet of identical trucks that cost $32,750 each. The company is allowed to depreciate the value of their truck for tax purposes by $52.50 per year. What is the linear equation to compute the value of the truck after Y after X years? Well, we know that the money is going, the value is going down by $52.50 every year. So, which means in this case, what we're going to end up having is we're going to have $327.50 as our starting amount. We are going to subtract $52.50 when the price of the discount, or actually the discount, you lose the value of that every year. So we're going to multiply it by X, and it's going to equal to Y. So the total cost is a $32.50 minus $52.50 times X. So from here, part 2, we're going to multiply by X equals 3 and see what happens. So I got 32750 minus 5250 times 3. Again, calculator. 5250 times 3 is, so I got 22750 equal 15750. You end up getting Y equal negative 7,000. Actually, not negative 7,000, sorry, positive 7,000. Sorry, positive 7,000. So after 3 years, the value was only $7,000. Okay, all right, and this is it. Hopefully this will help you get things set up for the story problems. If you got any questions, please let me know. All right, we'll talk to you later.